Hi everyone, welcome to the setup for the first lab, Circuit Basics. My name is Chris. Please just call me Chris. I don't care for Mr. Ertl or other stuff. I don't have a PhD, I have a master's degree, so I'm not a doctor. So if you call me Chris, that'd be great. If that makes you feel uncomfortable, professor's fine. I'm okay with that. So what I want to do here is kind of give you a little bit of getting to know maybe the lab device a little bit if you haven't used it before in a class before, and also get you just kind of started going with how to do these labs, because most of them involve circuits, and I know you are not doing circuits yet until later on in the class, so I'm going to try to make these labs be so that you are understanding them. I'm not assuming that you know anything about circuits going into it. So I'm going to try to help you learn circuits by basically doing these labs. Then once you get to it later in the semester, that should kind of make that part of the course a little bit easier. So I'm going to do my best to try to be very explicit about what everything means. Okay, so I'll be uploading the new video here because I'm making it now. But essentially all the labs, what you'll do is you record everything you do, all the questions that are in the lab report worksheet. You record them in there and you'll upload it as a PDF or a Word document, which would be fine too, to Moodle, to the Turnitin submission. So on Moodle, under the Labs tab, there is a zip drive or a zip folder for all the lab worksheets. So you can download them in Word or in Apple Pages, whichever your preference is. I've also have a link here so you can download the Word version of it right here on the website. For some reason, it won't let me put the Apple Pages on here. But so either which way you want to do it is fine. But you'll fill out that worksheet, you'll submit it to Moodle. Okay, and so basically what we're going to do in this lab is we're going to kind of learn how circuits work. Right? It's called Circuit Basics. So we're going to learn the basics about it. So for as far as connections, that's how circuits work. Everything has to connect somehow. So if you think of the electricity in your home, right? If you want the lamp to work, you have to plug it into the outlet, or else it's not gonna work. We're getting a little bit better now. Nowadays, like if you have a phone charger, sometimes you can you don't even have to plug it in. You can just place it on a little mat that will charge it that way. So that's a little bit of a different type of thing. But for the most part, we do things have to plug in to charge. Things have to plug in to run to get to their power somehow. So the basic device we use in electronics and building circuits is called the breadboard. So there's all different kinds of breadboards, and this is the one that comes in your lab kit. It might not be white, but it's a little tiny one. And basically the way it works, it's hard to see on the camera, but if you look on the top, you'll see on one side, on the top, it'll label the columns A through E on one side. Then there's kind of this dividing barrier, and it'll be F through J, right? Yeah, on the other side. Okay, and then it'll label the rows 1 through 17. Okay, so the way this breadboard works, and it's like this with all other breadboards, is that everything in row 1 is connected. Okay, all right. So we could call that first port. We could that hole, we could call it a port or a hole. We could call it 1A. The second one we could call 1B if we wanted to describe sort of their place, sort of like almost like a coordinate system for this. Okay. And so the divider in there means that everything on this side is separate from this side. Okay, and that's mostly what we're going to be using is this side. We will occasionally go to the other side, but we'll try to keep it as simple as possible for you. Okay, so all those ports in each row are connected. Okay, so that's how we'll make our connections. So there's some bare metal in there that will connect things. So the other thing we're going to need is some what I call jumper wires, and the ones that come in your kits, they look like this. Okay, and it has sort of like a little pin or plug on one end, a metal thing. Everything else is insulated. And on the other end, there's what we call an alligator clip, because if you squeeze it, it opens up like a little alligator mouth. Okay, so those are going to help us make our connections. And what we're going to do a lot is we're going to take two of them, and we're going to clip the alligators together. All right, so that they're connected. And what that allows us to do is to have a wire, a jumper wire with plugs on both ends. Okay, then we can plug one end into the breadboard, and we could plug it somewhere else in the breadboard, or we could plug it into one of the ports on the iLab device. Okay. Then as far as resistance goes, a lot of things have resistance. For instance, resistors. So in your accessory pack, you have some resistors, and so the ones we'll use today are going to be the 10,000 ohm. A little bit hard to see, but in the packaging, it's going to be labeled with an MPN, which is short for manufacturer's product number. And the 10,000 ohm one is going to end in J0103. Okay, and you'll also notice that there's like a clearly noticeable orange stripe. It's hard to see on the picture, but you'll notice that when you look at it, and it'll be labeled in the bag. And the other one is we're going to use a 1 ohm resistor. Okay, and you can see there that it's labeled J0109 is what the number ends in. Okay, so resistors have resistance. What that means is that they resist the flow of energy. Other things like LEDs you're familiar with, they also have some resistance, but they're a little bit different the way they work from how regular resistors work. So what we'll learn about in the next lab is called Ohm's law, which kind of tells us how all this resistance works with all the energy that we're using, and how fast everything is kind of moving around, how everything is working in the circuit. And so we call it Ohm's law because it's a law that typical resistors will obey, but things like LEDs don't obey Ohm's law. So we'll learn a little bit more about that in the next lab though. Okay, and then if we want to light up the LED like we're going to do in the first part of this lab, we need to have some power. Okay, and so your iLab device is going to provide the power. And if you were to open up the back here, and if you ever need to change the batteries, you just need a little Phillips head screwdriver to do that, and you pop that off, and you'll see that there's going to be 2 AA batteries in there. And so those are going to be our power sources, where we're going to get our electrical energy from to do all of these labs. And basically what it is since there's 2 AA batteries, each AA battery has like 1.5 volts. Usually if they're brand new, they're almost 1.6 volts. So there's about 3 or so volts that are in the device. And the device is very fancy. I mean, it's simple, but it's got interesting things. And we'll use a lot, like this first lab, we're going to use, there's a couple of these ports here that are called 3.3V. Okay, that means it's 3.3 volts. Okay, and the device actually regulates the power coming from the battery to make so it's exactly 3.3 volts. Okay, right, you know that in a battery there's a positive and negative end, and it's sort of going to be the same with circuits. We got to be careful where we put the positive, where we put the negative sometimes. So the positive is going to correspond, at least in the first lab, to that 3.3 volt port. And the negative is going to correspond to the ground port. And there's a few of them labeled in G and D, all right? And you can use any one they want, they'll do the same thing. And that's how we'll form our circuit, by having everything connected, power positive to negative. And I don't want to throw too much at you because I don't want to, I know you haven't learned all this yet, so too much is gonna just throw you out the window and get you lost. Okay, so so for this first part of the lab, we're just gonna try to light up the LED. That's it, right? And so what we're gonna do is, you can see how I've connected it in the picture, and I've told you in there exactly what ports I put them in. Like I put it in 1C and 9C is how I put that red LED in there. And you have two, you have a red LED and a green LED, and you should be able to use either one of them. So you just want to kind of take the little paper and tape off there. And mine's a little bit, tape's kind of stuck on there, so I'm just gonna use my fingernails to kind of clean that off, because we don't want anything interfering with the connection, or the energy won't be able to flow through, because the electrical energy needs a conductor to flow through. All right, so it needs that bare wire. And one thing you'll notice is that if you have the legs of the LED straight, then you'll see there's two of them, and one of them is a little bit longer than the other, okay? And so the longer one, I'm gonna put toward, I'm gonna call that like the positive, okay? And so I'm actually gonna bend these. You can bend these a little bit. I'm gonna bend them so I can get them to fit into the ports, okay? Okay, and then the longer one, I'm gonna put near in row 1, okay? Because the way I have it set up in the picture, if you want to try to follow along with that, if that makes things easier, is I want the long leg, since that's positive, I want that connected to the positive end of the IOLAB device, okay, which is the 3.3 volts. Okay, so I'm going to take, for the positive end, I'm going to connect that. So I'll just plug a little wire in there, and then the other end will go into the 3.3 volts. Doesn't matter which one you pick. Okay, and then to form our circuit, I'll just take another pair of wires, clip the alligators together. So I have plugs on both sides, and I'll plug the other end of the LED. Okay, and that will be our negative side. Now, so that will go into the ground on the IOLAB device. Okay, so now we have a complete loop. Okay, we have a complete pathway for the energy to flow through. All right, and so now we've got a complete circuit. We can test and see if we did it right. Okay, so you'll know if you got it right if the thing will light up. So I'm going to open up the IOLAB software for you here. Okay, and be sure if you haven't used the IOLAB software to you can follow there's a part in the lab manual in the appendix, okay, under the contents tab, where you can learn how to install the software, calibrate it, look at your data. So make sure if you're not that comfortable, and if you're not coming to the live lab sessions, that you take a look at those to kind of get a little bit familiar with how to actually use the software here. So basically what you can see up here on the top here, it's saying I'm paired. Okay, that's because I plugged the USB, right? There was a USB dongle in here, took it out, plugged it into my laptop. And now if I press the power button, all right, we see that it turns to connected. Right? And immediately, as soon as I turn it on, you can see my LED is lit up. Okay, so that's how I know I've got everything hooked up correctly. Okay. All right, so that's essentially all you have to do for part one is light up that LED. Just to kind of get you comfortable with making a circuit, be sure that everything's working right, that you're, you know what you kind of got a good start here, okay? One thing to note is that the iLab software, if you don't use it for several minutes, it will shut off, okay? So if you notice that, you're just gonna have to click the on button on the device again to get it going back on again. Okay, and I try to include pictures as much as I can so you can follow along and see exactly what I'm doing. Hopefully you don't rely on them too much, but if you do need that extra help, then it is there. Okay, so voltage, I'm sure you've heard of voltage before. We've talked about it a little bit here. We know that batteries have a certain amount of voltage, and so one way to measure voltage is using what we call a voltmeter. Usually people who deal with electronics, they have what we call a multimeter, which can measure all kinds of things like voltage, current, resistance. And so your kit doesn't have a multimeter or dedicated voltmeter, but we can actually use it. Sort of does have its own built-in voltmeter, actually, in a sense. And so that's how we're going to measure voltage. Okay. So in this part, you'll see we're going to replace the LED with one of the 10,000 ohm resistors. Okay, so remember that's one of the ones that has the orange stripe on it. It's in the bag labeled with the MPN, the manufacturer's product number, ending in J0103. Okay, and then you'll pop that in right where you have the LED plugged in. And so with resistors, it doesn't matter which way they're connected. There's no positive or negative on a resistor like there is on an LED. So you don't have to worry about how you've got that plugged in. Okay. And then we're going to use something called the A7 port. So you'll notice that on your device, all right, all the way in the bottom row over here, you see A7, which stands for analog 7. Okay, and we're going to get another wire. Okay, I'm going to put my resistor in, and you can bend the wires to get them in however you need to. They're not going to break. Okay, then we're going to make another wire. So we'll take two of our alligators and clip them together again. Okay, and then we're going to connect that A7 port. Okay, so I'll plug it into the A7, and then we're going to connect it to any other port in row 1. Okay, it doesn't matter, but try to be consistent with the picture. I'm going to plug it in to 1E. Okay. All right. Now, if we go to the software, we're going to choose the analog 7 sensor. Okay. We'll choose that, and we'll see here it's going to give us it's going to provide us with a graph, and it's going to be over time, and you can see the highlight it here, but you can see in parentheses the units are volts. So this actually this sensor measures voltage. Okay, so in a sense it is you can consider it a voltmeter. Okay, and it will measure the voltage between wherever you have the A7 port plugged in, okay, which is row 1, so this side of the resistor. It'll measure between there and the ground, which we already have plugged in over here. So basically we're going to measure the voltage that's going through that 10,000 ohm resistor, right? And sometimes we call that a voltage drop. Okay, so we'll click record and we'll let that go a few seconds. And then we can click stop. And we're already on the little data collection toolbar. So what I can do is I can kind of click and drag over that area. And then remember that the Greek letter mu here, that gives us the average over the part that we dragged over. So we can see we're about 3.3 volts going across that, which is what it pretty close to is what it should be because we have it plugged into the 3.3 volts port on the IOLAB device. So we can see that that is a voltage drop of 3.3 volts. And I wasn't recording the whole time. I was recording this, wasn't I? All right, so let's go over to there. Okay, so we'll try this again. Okay, so we click the analog 7, we click record, wait a few seconds, click stop, and remember our data tool is here, click and drag across that, and then the mu here gives us the average voltage, right? So this is, we see our units here are volts, V in parentheses, we're going over time, and that's our average voltage. Okay, so hopefully you watch those videos, or if you haven't already been familiar using the IOLAB device and seen how to use the software. Okay, now let's try going back to the lab manual. Okay, so one other thing we'll learn, you'll learn later on, is about schematic diagrams. And we know that with everything that we made here, right, we're kind of messy, right? It's hard to follow what's going on. So a schematic diagram kind of basically simplifies that mess, okay? So so here you can see there's a symbol for a power supply, and I labeled it 3.3 volts. And we have our 10,000 ohm resistor, that's a symbol for a resistor. And then our volts meter is just a circle with a V. So, so don't worry too much about what all this means. You'll learn about that later on, but I just wanted to kind of show you how this simplifies. Okay, then I'm talking about in step 5 here of part 2 a little bit, getting into Ohm's law, which we'll really get into next for the second lab. But essentially, Ohm's law just tells us the relationship between voltage, okay, resistance, right, of whatever we're putting in the circuit, like we did the resistance. The resistor here was our only real resistance, and currents. Okay, and we'll learn a little bit more about current. Okay, and basically, this relationship just says that voltage is equivalent to current times resistance. Okay, and then part 3, we'll do what we call a series circuit, which means that there's only one path for the current to flow through. Okay, and you'll see here, I'm not going to go through every little step here in the lab, but you can see and follow along how I place the two in series, okay, and get a voltage drop across those. And then we'll have up here, we had two 10,000 ohm resistors in what we call series. And then the second one will actually take out the 10,000 ohm and put a 1 ohm in there. And you'll see what kind of special meaning the 1 ohm is going to have. Okay, I have some pictures included here. And then at the end, you're probably going to want to keep the circuit set up for the next lab, because that's what we're going to start with in the following in lab 2, Ohm's law. Okay, and I do mention, so I'll just show you this one last thing before I let you get to it. But the high gain sensor you're going to end up using here in step 6 of part 3. Okay, and you can see here the ports where I plug it into, and I'll just quickly show you on the software. Okay, so remember, if if it timed out, then just turn it back on again. But to get out of this, I just hit reset like 2 or 3 times, and that will allow me to choose the high gain sensor. Okay, and so it's just there. And the high gain sensor, you'll see, will measure between whatever you connect on the device. There's 2 ports right here called G minus and G plus. Okay, so that's the high gain sensor. All right, so that's just a little bit of introduction to how these labs are going to work, to help you get started with this first lab. All right, don't take the video as a replacement for the instructions in the labs. The videos are more meant to try to help you understand things that are a little bit difficult to convey in words, okay? And to try to show you these things. But I try to also make really good close-up pictures of my setup so that if you need that to try to follow along with that, then you can. Okay? So I hope you have a good time with this. Hopefully you can join one of the live lab sessions, work with a team. That's really going to be beneficial. I definitely find people do the labs, get them done quicker, have a better experience when they can, even if you work on your own and give it a try, but then come to the live session and kind of work with others, help each other out with what you learned and what you couldn't figure out, you can get help with, and I'll be there during some of them, and our TAs will be there as well. So, all right, so hope to see you at one of those sessions.